Okay, so 8.4 is basically going to be applications of trigonometry. So it's still SOHCAHTOA. You just did those 3-word problems at the bottom and you had no problem with them. It's still SOHCAHTOA. There's just 2 vocabulary words that you need to be familiar with what they mean, because you're going to see them. They weren't in those problems you just did, but you're going to see them in problems that you'll see in the future. Okay, so it's basically word problems. The 2 words that you need to learn are the angle of elevation, and we're going to define that, so leave a little space, and then the angle of depression. Okay, so what does elevate mean? Lift up, right? Like an elevator. Of course, that goes down too. But if you elevate your legs, right, you're going to put your legs up, right? Elevation is up. Depression is down. Okay, so basically an angle of elevation is the angle looking up, and the angle of depression is the angle looking down. Needs a little bit more explanation than that. So it's the angle at which you look up at an object from your line of sight. I have to define that also. Okay, and an angle of depression is the angle at which, and again, this is just going into your notebook on a blank piece of paper. You look down at an object, again from your line of sight. Okay, so your line of sight is parallel to the ground It's basically the path your eyes follow when looking straight ahead. Okay, so I'm going to illustrate this a little bit for you. Okay, so I'm going to tell you a story. You get to choose which story you want to hear first. I have a story about a princess. I have a story about a fireman. And I have a story about a sailor. Which one would you like to hear? Fireman? I heard fireman. Okay, so we're going to hear a story about a fireman. And you are going to witness my expert artistic abilities here. Okay, so here's the ground. And here is our fireman. Can you tell that's the fireman? There he is. Okay, and I heard somebody guess it. There's a kitty stuck up in a tree. Or a rat, whatever, whatever you might think that is. Yeah, he's got too round of a tail. Now it's a rat. All right, well, anyway, it's a kitty up in the tree. And fireman wants to rescue this kitty. And he needs to figure out how high off the ground that kitty is so he knows which ladder to bring. I don't know. So the fireman's line of sight is looking straight ahead, parallel to the ground. This is his line of sight. So you should be drawing this diagram. You can just do little, stick figures, whatever. So that's his line of sight. It's parallel to the ground. So it's like as if he's looking straight ahead. But to see the kitty, he has to look up. So that's the angle of elevation, right? So this, that he's looking up, is the angle of elevation. Because he has to look up at the kitty in the tree. So he looks up at this kitty at about, I'm going to say 48 degrees. I'm just making this up. Usually these numbers come out really, really outrageous, but 48-degree angle of elevation. So if this was a word problem, that's exactly what it would say. It would say a fireman looks up at a kitty in a tree at a 48-degree angle of elevation. Okay? Now, based on the fact that we are going to think of this as being straight down, straight down from the bottom of the tree, let's say, okay, that is a right angle. Now, the problem is the angle we really are going to look at is part of the triangle that we formed here. And this is actually the triangle that we formed here, right? Because from his eyes to the ground isn't really part of the triangle. You guys see that? So, does it matter? Yeah, it does matter. Because his height is not part of the triangle, or at least from the ground up to his eyes is not part of the triangle. So we kind of have to know that distance. So the fireman might estimate, well, I'm about 6 feet tall, or I'm 6'2", so up to my eyes is about 6 feet. So we'll say that's about 6 feet tall. So are we ready to figure out how high up off the ground the kitty is? We need one more piece of information, right? So in this situation, what could he actually measure? Yeah. He could measure how far he is from the tree. So this is the distance that typically we're going to be given. All right, so let's estimate he's about, I'm going to go a little bit further than 20. Let's say 27 feet. Oops, that says inches. It's not 27 inches. 27, oops, now I'm yellow. 27 feet. Okay, so do you see the triangle we're working with here? We got 27 on the bottom. We got an angle of elevation of 48 degrees. We want to know how high this kitty is off the ground. Actually, let me make this x. Okay, so we're going to solve for x. What we really want to know is how high the kitty is all the way from the ground. I'm going to make that h. Exactly. Right, so we're going to solve for x. Again, we're going to decide, are we going to use sine, cosine, or tangent? Here's our angle of elevation. That's going to be our reference angle. X is what we want to know. That's opposite. 27 is what we know, and that's adjacent. So what are we going to use? Tangent of 48 over 1 equals opposite over adjacent. Now we're going to solve this. We're going to get x equals 27 tan 48. And on our calculator, 27 tan 48 about 30. So x is approximately 30 feet. Okay, so we know from here up to the kitty is 30. What is the kitty's distance from the ground? 36. What did you say? Right? Didn't you say that before? 36? Yeah. 36, right? Because it's the 30 plus the 6 feet for his height from the ground to his eyes. So plus the 6. So don't forget about plus the 6. Oops. So 36 feet is going to be our final answer. Little kitty. Okay? All right. Would you like to hear princess or sailor? I think the boys picked the first one, so we're going to go with the princess. I like the princess one anyway. Okay. Okay, we've got poor Princess Sokotoa up in her castle. Woe is me, says Princess Sokotoa. She's going like this, which they can't see on the video. Here she is, Princess Sokotoa. So far she's bald. Let's see. Let's give her some purple hair. Let's give her some purple hair. Because she's Princess Sokotoa. There we go. Oh, she looks a little bit like Witch Sokotoa. But anyway, okay. Here she is saying, woe is me. My evil stepfather. It's always the mother. We're going with the father this time. Locked her up in this tower. She can't get down. So woe is Princess Sokotoa. Never fear. Along comes it's going to try to be. It's a horse. Galloping. He's got a broken leg or something. I don't know. And of course, who's riding on this horse? Prince Charming, of course. Prince Charming is coming. He's coming with his sword drawn, ready to rescue or chop off her head. I'm not sure which, but okay. Princess Sokotoa. He's a prince, so we'll give him a crown too. You don't have to draw it like I'm drawing it. I'm just trying to be entertaining here. Never fear, Princess Sokotoa. Here I come. He's got black hair. Okay? Here go. There we go. All right, so here he comes to save the day. Wow. All right. So Princess Sokotoa sees him, and now she's happy Princess Sokotoa. She's missing a hand or two. Okay. So anyway, here's the princess's line of sight. Remember, it's going to be parallel to the ground, so it's when she's looking straight ahead. And now, what does she have to do to see the princess? Look down, which is an angle of depression. Okay. Now, here's the thing about the angle of depression. This is the one that has a little twist to it. Okay? Because the angle of depression is from when she's looking straight ahead, how many degrees she has to look down. So where is the actual angle of depression? It's here. Okay? It's not here. It's here. Okay? So the angle of depression is only 12 degrees. Looking down. This time, she happens to know how tall her tower is. She doesn't know how far away the prince is. That's what she wants to know. She wants to know how far he is away, so how long it's going to take him to come rescue her. But she knows how tall her tower is. And her tower is... That's really tall tower. Let's say and the horse is 80 feet tall. But no, okay. So let's say that from the ground to her eyes, she's thinking is about 53 feet. About 50 feet for the tower, about 3 feet up to her eyes or whatever. I don't know. So 53 feet is what she's estimating the height of her tower. So the triangle that we have formed here is kind of like this. So what do we need to know in order to have a side that we can use here? The angle of elevation is here, but that's a good point. Is that angle actually in this triangle? You could use 78 because 78 plus 12 is 90, and we know that that's about 90. But you also could alternate interior angles, right? You could just take this angle measure and put it here because it's alternate interior. Grace did. Alternate interior angles. So instead of doing the subtraction from getting 78 degrees, which you can do and it will work, you could just switch it down, and it almost is like the angle of depression from her perspective is equal to the angle of elevation from his perspective, right? Okay, so, but we still need one more thing because 53 degrees is 53 feet is really more than what we have in our triangle. So we would probably have to estimate, or we would have to be given in a word problem, how high off the ground we're figuring this horse is, right? So let's say, what's that, about 10 feet, 6 feet? Yeah, 6. 6 is about right. So let's say this is, well, him. Let's just say 6. Right, whatever. It doesn't matter how accurate we are, but so it's about 6 feet. let's say. Okay, so then we know that this piece is 53 minus the 6, which is 47 feet. So you can see angle of depression is sometimes a little bit trickier. Well, it was the 53 all the way to the ground minus the 6, 53 minus 6 equals the 47. Okay? All right, so then we finally can actually do some trigonometry here. We have, what we're trying to figure out is this, how far he is from the base of the tower. So we have, again, opposite and adjacent. Okay, so we have, again, opposite and adjacent. So we're going to do tan 12 equals opposite 47 over adjacent x. Right? This is opposite. This is adjacent to our reference angle. So this time we have x tan 12 equals 47. So we have to do a division on our calculator. 47 divided by tan 12. Right? Because we're trying to get x by itself. So we're going to divide by tan 12 on both sides. So whenever x is on the bottom, it ends up being a division. 47 divided by tan 12. "221 feet away." That's actually not that far. On a horse, he'll be there in no time. Okay, so there's a couple things you have to remember. The tricks of this lesson is angle of depression, you got to remember, is looking down. So sometimes it's not part of the triangle you know about. So you have to kind of switch it into the triangle. That's one of the tricks. The second thing is the height of the person, the line of sight. You have to take into account how far the line of sight is from the object, or how far the object is from the ground. So there's that little differential that sometimes you have to subtract out. Not always, like you saw in some of the problems, like the ladder problem. You know, there wasn't, it's not off the ground, so there's not always that differential, but when it's a person looking at something, it's typically there is that, that situation. Okay. Sometimes there's going to be, it's not always tan. Both of these problems that we did were tangent. You're going to find that in word problems, it's really often tangent, but it's not always tangent. So don't assume it's tangent. You really have to set it up and figure out which one you're going to use. Okay.